everybody, I'm here with a quick video trying to kind of go over the similarity in right triangles that we didn't get to today, or that we started to and then kind of got tripped up on. So far I've been showing you kind of the ideas behind similarity in right triangles and how really all we're doing is finding the scale factor and using proportions to determine the unknown side lengths of x and y given our similar right triangles when we have kind of three different triangles nested into one. So I really do think you guys have a really great understanding about what's going on and where these equations are coming from, but as we saw today in class, it's still really difficult to figure out exactly how we should line up the triangles and which sides are proportional to the others ones. So I'm going to try and show you a different way as to how you can approach these questions using geometric mean. So to start, I have this equation that we were working on today in class. So we have our big triangle, ABC, which is similar to this tiny triangle, ABD, which is similar also to this triangle, DBC. So now one thing you can use in trying to figure out how to set up your proportions in order to solve these kinds of equations, to figure out what x and y are, is to use this idea of the altitude. So I have written out here that the altitude is the geometric mean between the two pieces of the larger triangle's hypotenuse. Now that at first glance seems like a lot of words, so let's kind of break it down step by step. So first off, what is the altitude? The altitude is the line that splits that big triangle, which is right here that I've outlined in yellow, into two smaller triangles. So in this case, the altitude would be this line segment right here, this BD. That's the altitude that we're dealing with. So I've said that the altitude is the geometric mean between the two pieces of the larger triangle's hypotenuse. So I'm saying that this altitude, this BD or Y value, is the geometric mean between the two pieces it splits. And it splits this AC line into 10 and 8. If you can see that right here. You see how it splits this AC hypotenuse for that large ABCD triangle into two pieces, 10 and 8. So what is geometric mean? Again, let's kind of just have a little refresher before we dive into this, into the triangle standpoint. So remember that the geometric mean between two numbers, A and B, is the value x, where x is defined by this equation, A over x is equal to x over b. It's this weird proportion that has nothing to do with how you found averages before. It seems kind of like it comes out of left field, but it is very helpful for approaching these right triangles, which is why we're going to go back to it. So for example, if I asked you to find the geometric mean between 3 and 27, for instance, we would do that by setting up our proportions. 3 over x is equal to x over 27, and then the geometric mean, remember, is x, so we would cross multiply to have, and 3 times 27 is 81, so 81 is equal to x squared. Take the square root of all of that, and we get 9 is equal to x, which is equal to the geometric mean. Okay, so that was all kind of a review. Now to go back to what we were saying here. So we're saying that the altitude, again, that weird piece in between that's splitting up this big triangle, is the geometric mean between the two pieces. So remember, the geometric mean, when we were doing this example, is that x. Here the geometric mean is this piece, which in this case is equal to y. So what this is really saying, what I have written here in the purple, is saying that y is the geometric mean between the two pieces 10 and 8. So 10 and 8 are our two numbers, and y kind of becomes that x value. And you can kind of see how this is similar to that A and B proportion that we set up over here. So here 10 and 8 are kind of like our A and B from the geometric mean question that we were dealing with over here. And y is that solution to the geometric mean, or that x. So for instance, if we were going to now solve this question, rather than even going through the crazy chaotic steps that we've been doing involving rotating this triangle around and rewriting them and figuring out which is the long side or the short side or the base of the hypotenuse, we can instead just kind of use this idea of geometric mean and the altitude to easily say that we know that 10 is to y as y is to 8. Because y is the geometric mean for the numbers 8 and 10. So we know that that proportion is always going to be true. And if we know that's true, we can easily solve for y by cross-multiplying. And now we have 80 is equal to y squared. Take the square root. Y is equal to the square root of 80. And normally you would want to then simplify this radical expression down a bit, but for time's sake, I'm not going to do that here.